So question number 21. A wire of length 1 meter and mass density 4 into 10 to power 3 kg per meter cube, stretched between two clamps subject to an extension this, Young modulus of the wire is this, then frequency of the first overtone of the transverse vibration in the wire. Okay, so frequency of first overtone I can write 2 times of nu naught. Nu naught is the frequency. So 2V upon 2L, I can write V by L. V is the speed and nu naught is the frequency. And the speed you can calculate T by rho into A. Rho is the density, A is the area. So nu is equal to P upon L, I can write this. Now, for tension T, I can write Young modulus Y into A upon L into delta L according to the problem. So I can calculate T by 4 into 10 to the power 10, 3.6 into 10 to the power minus 4 into A, divide by 1. So now I am going to calculate speed V. V is 4 into 10 to the power 10, 3.6 into 10 to the power minus 4a, divided by a into 4 into 10 to the power 3. When you will calculate, will get speed 60 meter per second. And now I am going to calculate the frequency, and that is nu. Nu is equal to V by L. V is 60, L is 1 according to the problem, then we'll get 60 Hertz. So my option number 2 will be the right choice. So we'll move the question number 22. In the problem number 22, the fundamental frequency of two open pipes different lengths are 200 Hertz, 300 Hertz frequencies. If they are joined to form a longer pipe, then frequency of the third harmonic of the longer pipe will be. So you know the fundamental frequency, or according to the problem frequency, nu naught is given by V upon 2L. So if I go for L1, so we'll write here V speed 2 times into frequency, that is in the case number 1 this is 200 Hertz. Similarly, if I go L2 speed V 2 into frequency 300. So after joining the pipes, frequency of third harmonic will be nu is the frequency, and 3 times of V means speed, 2 times of L1 plus L2 the total length. So nu equal 3 times of V, 2 times of V upon 2 into 200 plus V upon 2 into 300. So on solving, you will get the value of nu is 360 Hertz. So this is how you can solve the question number 22. So my option number 4 will be the right choice. So let's move on question number 23. In the question number 23rd, the frequency of fifth harmonic pipe closed at one end. This is very important, 680. If the speed of sound is 340 meter per second, then length of the pipe will be. So you know the fifth harmonic will write in the closed pipe 5 times of V upon 4L. As I said earlier, in this type of question you need the formula. So frequency is equal to 5 times of speed and 4L. So you have the value of V. The frequency fifth harmonic was 680. So you will write here 680. 5 you need speed, that is 340, and 4 times of L. You can see L is only a known variable. So by this expression you can solve the value of L. On solving you will get 62.5 centimeter. So my option number 3rd will be the right choice. Let's move on. Question number 24. In the question number 24, two sound wave of wavelength 1 meter, 1.02 meter produce 16 beats in 2 seconds. This is very important because beats per second. But here 16 beats in 2 seconds. Medium, then velocity of the sound in that medium is. So you know The beat frequency is F1 minus F2, but that is number of beats per second. So you will write number of beats per second means divide by 2. F1 V is equal to, here you can write like that, speed upon lambda 1 minus speed upon lambda 2, because I am going to use V is equal to F lambda or N lambda. So first V upon 1 according to the problem, V upon 1.02. So when you will calculate, because V is only unknown, so when you will calculate, you will get V is equal to 408 meter per second. So in the question number 24, option number 1 will be the right choice. Let's move on question number 25. In the question number 25, two identical stretch wire have a fundamental frequency 200 vibration per second. When kept under the same tension, what percentage increase in tension in one wire will produce 4 beats per second when both wire vibrates together and delta t is so less than t? As I said, number of beats per second is F1 minus F2 difference in frequency, and for frequency by the law of tension, you know 1 upon 2 times of L, tension and linear mass density. But you know the length and linear mass density will remain constant. So if I go for the percentage change, then we can write with the help of this formula, change in frequency like that, 1 by 2, because under root will be there, t by t. So this is the relation you can write. As per the question, 200 vibration per second and tension will remain same. So in place of this, I can write 4 upon 200 vibration, 200, 1 by 2 into delta t by t. Now we can write like that, delta t upon t, and 2 into 4 means 8 upon 200. In terms of percentage, we will multiply with the 100 on both sides like that. So when you will solve, you will get 4%, because 0 will cancel out and 2 4 ja 8. So by this calculation, I can say the option number 2 will be the right choice. So let's move on question number 26.